Tungsten carbide cobalt is a high melting point material. Tungsten carbide cannot be made by any other process other than by powder metallurgy, because if you use tungsten as a material, even tungsten melts at a temperature about 3,000 degrees, and tungsten carbide doesn't melt at all, but it dissociates at temperatures above 3,000 degrees centigrade. So there's no other way of producing tungsten carbide. Now, we need tungsten carbide and the metallic cobalt as well, and this is a composite material which cannot be cast or forged. It has to be made by press and sinter technology. So we are thankful there is no other way of doing it. Powder metallurgy technology gives us also the possibility of making near-net shape products by direct pressing, or by direct pressing plus a pre-sintering and machining, or using other methods like extrusion or powder injection molding to make complex parts. The new press technology also gives us the possibility to make products with multiple functions, like by using a core rod going through the middle of the insert as an example, or by using, let's say, different punches at different levels to make very complicated tools which are not really flat. So for tungsten carbide, cobalt, hard metals, there is no alternative to PM. Hard metals are characterized by their wear resistance and toughness. There is no other material in the world that we know now which has this very good combination of hardness and toughness. When they started off making hard metals in the 1930s, let me see, 1 gram of hard metal would cost has the same price of 1 gram of gold. Today, 1 gram of hard metal could cost maybe 10 euros up to maybe 100 euros, but still comparatively cheaper. The main reason why many people do not adapt hard metal is much more expensive than steel, number one. And number two, to grind or machine hard metal, you need diamond grinding wheels. And a normal job shop doesn't have diamond grinding wheels because these diamond grinding wheels are also expensive. But the prices have been coming down. Availability is more. We can make more near-net shape. That means we need less post-sintered machining. So the areas where hard metals are growing are two different types of hard metals, actually. One is in very fine grain material. That means grain size below 0.8 micron, going down to the nano area of 0.2 microns in the sintered carbide. We get very high edge toughness, hardness, so we are able to use these very fine grain materials for round tools which need a very sharp edge also after a coating. In most cases, this is a PVD coating which is used. And this PVD coating, together with the very fine grain size, gives the hard metal a very tough, but also a very good cutting performance because you have a sharp cutting edge. So one area is for growth is in round tools. It could be for metal. It could be for aerospace. For example, Airbus A380 has about 50,000 holes, 3/8 inch diameter. And each of these holes has to be exactly perfect. It's a composite material with the CFC on the one side and titanium or aluminum on the other side. And we can use only carbide tools which have been coated. And in this case, the coating is diamond. So there's a big growth area for aerospace. The same applies to aluminum-based alloys. Everybody wants to downsize, everybody wants to reduce the weight, so we're going to more engine blocks, engine heads made out of aluminum, and for aluminum machining, carbide is a big growth area. But the other areas, like in mining, the number of people on Earth is growing, but the standard of living is growing as well. Everybody wants to have enough food and have iPhone and whatever you name it, everybody wants the same thing. So we need to get more resources out of the earth. And this is only possible nowadays, and it was always that way, to use carbide tools. So the growth in the mining area, whether it is only for getting new resources or for getting down to the deep bowels of the earth to get the coal or the gas or the oil, this goes on only with carbide. Now, we are all very eco-friendly, and everybody says we are ecologically friendly. So a large part of biomass, which has to be cut down before it's fired, they're now cut down using carbide-tipped tools as well. If you go to a dentist, and I have 3 implants in my mouth, I saw the tools, they're all carbide-tipped. And as we grow older and older, we'll need more implants in our mouths, or we can afford it. So in medical sector, not only for your teeth, but also for your hip and knee joints, to fix them, these are drilled, the plates and the screws are drilled using carbide drills. Think of a ball pen. Even though we have computers, nowadays we have about 5 billion ball pens made with carbide tips. And this is growing, still growing, because we have more people, and everybody owns more than 1 ball pen at home. So this is another huge area. Wear parts, anything which you can make out of steel can be replaced partially through carbide. But we need the right engineering, the right design. And if you look at the past 25 years, in Europe, the production of carbide has increased 3 times. If you go to China, the production of carbide has increased 10 times. And Europe is much smaller than China. So there's a huge market as well in China and in the world, independent of the productivity gains that we're making day by day. So I'm very confident that as long as we get the raw material, hard metals have a very bright future.